entire concept related to your exception handling in Java, right? And this is one of the most important feature of our Java programming language, because during that time when James Gosling and his team, basically when they have basically worked on this Java programming language, then at that time no other languages are basically working on and having the features like your exception handling as well as like multi-threading like that. Okay, so they have worked on that, and that's why at that time and is still now Java programming language is more popular than your other programming language, right? So in today's lecture, we are going to start with one more feature of your Java programming language, that is your multi-threading. Okay, so some of you have already heard about this keyword that is known as your thread keyword. So where you have heard this thread keyword, I can tell you like whenever you are getting some error, okay, in your Java programming language, then you got some sort of message, and in that message it displays something like thread, that the thread of main like that, okay, whatever the error or whatever the exception you are getting at. So at that time, you have basically gone through this word that is known as your thread. So in this today's lecture, what we are going to do, first of all, we are going to discuss about what is multi-threading. Then we will find out that what is thread, then what is a scheduler, what is thread life cycle. All these things we are going to cover in our today's lecture. So let's start with the concept. What do you mean by multi-threading? So I will give you some real life examples too, so that you will have a better understanding about what do you mean by multi-threading, right? Like this. Now, what do you mean by multi-threading? So let's go for the theoretical definition that multi-threading is a Java feature that allows concurrent execution of two or more parts of a program for maximum utilization of CPU. So till now, if you will ask me, or if I'm going to ask you, like, okay, in all of your problems, okay, like in your lab problems, as well as if you are working in a project, then there is a very high probability that all of you are working in a sequential manner, okay? Sequential means it will follow the sequence, means you are not working, you are not basically working on some sort of creating some programs which basically work on in a parallel manner, right? So what we are doing over here is that we are basically working in a sequential manner, means it will go line by line. So if we have a program P1, so what we are generally doing, first of all, P1 first line will execute, second line, and so on like that, okay? So this entire program will get executed in a your sequential manner. Now using our concurrent, your multi-threading, okay, kindly mute your mic. Yeah, so by using multi-threading, what we are doing, right? So in the case of multi-threading, we are basically going to learn about this technique too. But right now I'm just telling you is that key, what we are doing, we are basically dividing this entire program. Suppose this is our program P1, right? So we are going to divide this entire program in such a manner so that we can execute our this P1.1 as well as P1.2 parallelly. Okay. So there are some condition that these two code, like suppose this is my C1, this is my C2, that so that these two codes are not, means they are independent to each other. Okay, they are not dependent to each other. So we can do it like that. Okay. So what is the advantage? As you can see over there, the main advantage here you can see is related to your speed, right? So nowadays you already know that because nowadays we are using our phones. Okay. So what we can see over there, how we can say that, okay, our mobile phone is better than other phone. So first of all, we'll see that, okay, how many parallel simultaneously, how many applications we can run. Okay. So if our laptop, desktop, or anything like our mobile is able to basically operate or many processes, okay, your or many application parallelly, so we will say that okay, our mobile, this mobile is better than that particular mobile. If we are talking about some layman term, okay. So basically, similarly, so how we are performing that your concurrency, okay. So there is a term that is known as your multi-threading. So using this concept, we are able to achieve and we are able to perform the task of your concurrent execution so that our two portion or to our entire program will execute simultaneously, right? And each part of such program is called a thread. So generally, whenever we have a process, okay, so process is what your program under execution. Okay, so always remember, like in being a computer science engineer, you should know about this term is that if somebody is going to ask you about, okay, what is a process, then you will always give them an answer that program under execution. Now, you will say that what do you mean by program under execution? So I think I have already told you about this concept is that whenever we are executing our program, right? So suppose your program is in your secondary memory. I'm not going in the detail of this memory, but still I'm just telling you what we are doing. We have a main memory. So what we generally do, we generally put, so suppose this is my P1 program. Initially, it is in my P1 memory, right? Now I want to execute this program. So once I will execute this program, then what will happen? This program will come in into my main memory. So whatever the operations which you are performing now, so all these operations we are performing inside our main memory. So that is why what will happen? Now we are processing this our entire program. That is why this any program that is under execution, we generally call it as your process, right? Now what we are doing, we are basically dividing this entire process, okay? Means process means program under execution, you already, into your various threads, okay? Various threads, how we are creating threads, like I have given you one instance is related to that. Suppose we have a program, so we divide our program into two or more than two parts, and in such a way we are basically executing our program so that they are executing concurrently, right? So now we are achieving what? We are maximizing maximum utilization of CPU. Now the question you will ask me, sir, how we are utilizing the maximum utilization of CPU? So you will find out that in our CPU, again, I'm not going in the depth because this thing you will learn whenever you are going to cover operating system, right? So we have a processor and we have here what I will do. Yeah, here we have a processor which will process our entire function, and here we have input output operation. Suppose you want to input output something like that. Okay. Suppose if we have a sequential processor, right? So during that time, what will happen? Suppose I am processing something, my processor is doing and performing some set of operation, and after some time, my this particular process requires some input output operation. So what it will do? It will basically go to our input output operation. Now let's assume here in input output operation, it is taking a lot of time. Let's assume, okay? Now what will happen during that time if somebody will ask us like, okay, what my processor is doing? Now we will say that our processor is doing nothing, okay? Because it is waiting for this particular operation. Now, in order to make, if we are using somehow, if we are using our multiprocessor, okay, if we are using the concept of multi-threading, then if one of the process is basically working on our input output operation, then what we can do, we can execute our other threads, okay, so that now we are able to basically utilize our CPU, okay. So we always want to utilize our CPU. This is our main goal, so that we are able to process as much process as we want. Okay, so basically in CPU, what we are doing, we are processing something. No? So if we are able to utilize our CPU, so we will get maximum output like that. Now each of threads can run in parallel. So till now, what you have learned so far is related to the concept of multi-threading. What is multi-threading? Means somehow I am not saying that you have an in-depth knowledge about this term, but now you have an idea is that okay, multi-threading is somehow related to your concurrent execution of two or more parts of program. Okay, so we want parallel programming. So that is why we are using multi-threading, and our Java programming language is supporting our the concept of multi-threading. So till now you have an idea about this thing. Now you know that what are the applications of your multi-threading, right? So I can give you one example is that in your system, suppose nowadays if you are writing some code, right? If you are browsing something, so simultaneously what you are doing, it might be possible you might downloading something, okay, so downloading some file, or you are listening to some music too, okay? So parallelly you are performing a lot of tasks in your laptop, okay? So how you are performing it? Using with the concept of your multitasking, okay? We generally call it as the concept of multitasking, and multi-threading is you can say that an advanced concept how we are basically performing this multitasking using with the concept of multi-threading, okay? So using multitasking, what we are doing, you are performing multitask. Nowadays in your laptop, what you are doing, you are performing several tasks over there. Okay. So this is one of the most important means main example of what we call it as your multitasking. Similarly, in your mobile application, you are using some application, and in backend, some of your applications are getting updated. So simultaneously, if you will see over there, simultaneously both tasks are performing in our mobile. Okay. So this is the example of multitasking. So we always want to perform multitask. So that is why we are going to achieve this multitasking using the concept of your multi-threading. Similarly, one more example is related to browsing, displaying images in web pages. So you can see that whenever we are uploading, okay, whenever suppose we are browsing or whenever we have opened some website like flickr.com, okay, so you can see over there all the websites you will get it, okay. But in reality, you will see that if your net connection is low, then you will find out that so first this website this particular image will open, then this web basically image will open, this image will open, something like that, okay. But then if your net speed is fast, the operation is similar, okay, but your net speed is fast, so that what will happen, or process your server processing speed is fast, so that now you will be able to see the entire images in a single frame, okay, in a single moment of time. But it is actually what is happening over there. First it will upload your this image, then it will upload this image, like that, okay. Now similarly, website whenever displaying ads, so you already know that how your Amazon, Flipkart, how they are basically using it, okay. So how they have created their recommender system, how they are using their advertisement in your whenever you are using your or accessing any website, something like that. So basically they have a query engine, okay. So using query engine also parallelly they are for giving you multiple suggestion of related to your advertisement. And last one is web crawlers. So you already have an idea about what do you mean by web crawlers, like your Google, okay. So Google or any search engine. So what they generally do, they generally use the concept of web crawler. Using this concept, what they will do, they will basically access, okay, index our entire web pages. So suppose if suppose I have created some new web page, so how my Google will understand? So what will happen? So they have some web crawlers which will parallelly they will access thousands and thousands of your web pages simultaneously. So if there is no concept of multitasking, or you can call it as parallel programming, then if I have to access 10,000 web pages, okay, I want to list 10,000 web pages on my this Google Google search engine. So how much time it will take? You can directly see 1, 2, 3, 4. It will go like that. But now using this parallel programming, what we are going to achieve, we are doing this entire task in a single fraction of second. Okay, in a single fraction, we are able to basically achieve this thing. So till now, you have an idea about what do you mean by what is the meaning of your multi-threading and what are the applications of multi-threading. Okay, so there are various. So nowadays, because we want our process should be fast. So this is the only way we can process our this fast. Okay, using the concept of your multi-threading. So till now, you already using your sequential programming, okay? So if I'm going to give you one program, so how you are writing your program? You are not using any multi-threading concept right now, okay? Still, I will tell you about that whenever you are writing any program, you are working in a single thread, okay? But you are not working on multiple threads, okay? Means you are not performing multi-parallel programming, but using sequential programming, you already know that certain tasks, suppose if one of the tasks is blocking some of the thing, then what will happen? It will halt your CPU time and thus wasting your CPU time. Means CPU is doing nothing. So if CPU is doing nothing, then what will happen? And it will wait. Then we are not able to process as much we want. Okay. So we don't want to wastage the CPU time. So what is the solution of utilizing our CPU time? And the answer is our concurrent programming. Okay, so how can we achieve concurrent programming? Using multi-threading. So this is the main motive. Okay, so whenever you are learning something, some new concept, so it's not like that, okay, we have to learn it. No, first thing is that what is the main motive, why we are learning multi-threading, why they have incorporated this concept? Is there any advantage of that? So yes, you can see that because here we want to utilize maximum utilization of our CPU time. So that is why we are going for the concept of multi-threading, and using that we are performing concurrent programming, right? So it helps in better resource utilization and your this your throughput. Okay, throughput means number of process, how many number of process you can execute at that moment of time. Okay, so if let's assume if we are performing sequential programming, so let's assume we can process in 1 hour. I'm just giving you an example. Let's assume in 1 hour we can process 10 we can process only 10 processes, right? But if you are going for your concurrent programming, so it might be possible like in 20 minutes, we are able to process your entire 10 processes like that. Okay. So this is how basically we are increasing, maximizing our throughput. Okay. So this, but there is something, okay, which we have to concern is that sequential programming are basically very simple, okay, because we are not at all concerned about whether this code, this part of the code is related to dependent on this particular part of code or something like that. But in the case of your concurrent programming, you have to think about it, right? Got the point? So you have to think about it, okay, whether this code will make an impact on this particular code or not. If it is not making any impact, then that is great. And what should be the order? So there, the complexity is very high. It's not very easy to just write down or just to break your code into multiple threads. No, it's not that much easier. Okay, so you have to find out, you have a very detailed knowledge about, descriptive knowledge about your entire code, how you are going to write your code, how you are going to utilize your resources. Otherwise, every time you will get different output, and you don't want that. Okay, so that is why the concurrent of programming is complex. But after, once we are going to learn and once we will get familiar, then you will find out that again this multi-threading is also a very simple concept. Okay, but whenever we are writing the concept of, or whenever we are writing programs related to multi-threading, we have to concern few topics, a few of the concepts. Okay, so these concepts we are going to learn in our upcoming lectures. So this is just an example. So this is just a sequential stream and this is a parallel stream. So you already know that we have core, okay, different. So let's assume for your processor, if you have 4 core and if you are using sequential stream, so you can see that these cores are idle, means they are performing nothing. And here you can see that a lot of queue 4 queue. Okay, the size of this queue is 4, and here we can utilize it, but still we are not utilizing it. Okay, but using parallel, you can see directly that how we are basically utilizing this entire resources. Okay, so this is just an advantage of your parallel stream. Okay, now you can utilize it. So here you are just performing. See, if I'm going to write down this, suppose 1, 2, 3, and 4 seconds. Okay, so it will take entire 4 seconds. Now 1, 2, 3, in 3 seconds we are able to process how many threads? 7 threads. But here we are able to process only 4 threads. Okay, so this is the advantage, and this is the power of our parallel program. Now, what do you mean by thread? So before going through this thread, I just want to give you an idea about our operating system too, right? I'm not again going in the depth, because our nowadays we have a operating system which will follow what you're multitasking, right? Like I have given you one example related to, like, you are listening music, as well as you are also writing code or something, or downloading some file, something like that. Okay, but once they have means post operating system era, and we generally call it as our batch operating system. Okay, when we have batch operating system, then what we have, we can execute only one program at a time. Okay, we cannot execute multiple programs at a time. So that is the main advantage, that in most of the time our CPU is idle, means it is not doing anything. So we want to utilize it. So that is why we have gone through the concept of operating system, which will manages our entire process, which will manage our memory. So our operating system is managing a lot of tasks, our processes, our memory, and something like that. Now, after operating system, what they have decided, that because we want to increase the performance of operating system, so they have used the concept of multitasking, so that our CPU switches from process to another process. So what actually is happening over there, if you are working on your means like means operating system, or your machines which are very older, then you will find out that you will easily find out, okay, these two, you will find some sort of lag. Okay, but nowadays your systems are very advanced. Now even you will find that there is a lag, but it is in your micro millisecond, something like that. Okay, so we are not able to find out whether it is a lag or not, but in reality it is somehow a lag, like that. Okay, so we are basically better resource utilization, and better resource utilization leads to the development of threads. So we want to utilize our resources. That is why we have come with the concept of our thread. Now, without wasting our time, let's start. What is a thread? So thread is a single sequential flow of control within a process. So what we have a process, right? Now this is my process. So what we will do, we uh, basically divide this entire process into your 3 threads. Let's assume. So generally we represent threads like that. Okay. So in all the books, whatever the books you are going to follow, they will represent thread right like that. No, this is not a means character representation. Okay, this is just a means graphical representation of a thread. Now in this thread, what will have, this is a sequential, means you cannot basically, it is inside your thread, you have to follow a sequential flow of control, right? It's not like that again thread you can perform multiple thread like that. No, you have to follow a sequential flow of control in a process. Now these are generally called it as your lightweight processes. Why? Because they required very less resources. Okay, they are sharing, all these threads are sharing same memory space. Okay, they have different they are sharing memory, but they are having their own program counter, stack, and local variable. I'm not going through this. What do you mean by program counter? Later on you will learn by your own. Okay, in some of the objects related to, I think in digital electronics, you already have an idea about what is your program counter, what is your stack you already have an idea, and local variable. Okay, so thread share processes wide resources, so within a memory, so they are sharing the same memory over there. Okay, so a process can have multiple threads. Now, using what you have learned so far is that using threads, you are able to achieve multi-threading. Now, how to create threads in Java programming language? Now we are going to learn about that part. But before, what are the benefits? So I'm again, so this is a kind of a repetition of a slide, is that we are achieving parallelism because we want to exploiting your multiple processes, always loosely coupled design, and better throughput even in single CPU machine. Okay, like that. Now, first of all, we'll discuss about what are the types of threads. So there are two types of threads. Okay, so first threads, we generally call it as your daemon threads. Okay, so in this threads, background threads which are useful for tasks such as garbage collection. So in we have already discussed about garbage collector. Okay, so similarly, in Java programming language, if somebody is going to ask you like who is like performing this garbage collection, then you will say that garbage collection performed by our daemon thread. So whatever the threads that are in our background, okay, which we cannot basically see, which we cannot code by our own, okay. So those threads are known as what we call it as your daemon thread, and they will always execute in our backend, okay. So you can see now that whenever we are writing our program, I have given you one example is that whenever we are writing new, suppose I am creating an object of some class, okay, suppose main, like this. And suppose if I'm not using this reference variable, then after some time, even before terminating our program, automatically what my garbage collector will do, it will delete this entire object. Okay, it will remove, because our garbage collector will have an idea that in future you are not able to access this object. How can we access this object? Because we don't have the address of this particular object, right? So how, so parallelly you are performing this operation using this your daemon thread. Now what we are going to do, we are going to work on our non-daemon threads. So these are created within applications, right? Main thread. So all of you till now, whenever you are writing a public static void main, so what is, we are automatically, whenever we are writing public static void mains, we already have a main thread, okay, and it is created by JVM to run main method. So automatically, whenever, still if you are also working in thread, but we are not working on multi-threading. So if somebody is going to ask you like in your program, whenever you are writing any program, how many threads you are using? So you will say, sir, I am using one thread, and where this thread is in your main thread. Okay. And what is the main function of this main thread? It is created by JVM to run our main method. Right. So JVM will not terminate if at least one non-daemon thread is running. So automatically, if we want to terminate this thing, so we have to basically work on our non-daemon threads. So let's take this example. So here you can see that, let's assume this is a box of our construction site, and this entire construction site, if we are going to call it as your process, okay, if you are going to call it this entire thing is as a process, and these workers are, let's assume these are our, what we call it as your threads, okay, let's our T1 thread, T2 thread, and T3 thread. And we know that these workers are useless, okay, unless we will give some work, okay. So what we are going to do, we will give them some sort of task. Now they will execute this task simultaneously, they will execute this parallelly, okay. So similarly, if you want to create these threads in your Java programming language, so there are two ways, okay. So we are going to discuss about, but right now I am just going to give you an overview so that you will have an idea about this thing, is that either you will use this java.lang package, so your dot thread, and do using with the help of java.lang.runnable. So using two ways, basically we can work, or we can create we can use the concept of multi-threading. Either this, here this thread is our class, okay, here this thread is our class, and this runnable is our interface. So by via two ways, basically we can start working on our the concept of our multi-threading, right? So right now, what we have learned so far is, what do you mean by multi-threading? What is a thread? Okay, what are the advantages? Now you know about all those things. Now we are going to learn about that in Java, how we are going to create our own threads, right? So whenever you want to use, so already you know that we are, so why we are performing the task of multi-threading in Java, because Java supports multi-threading, right? So that is why it means they have some inbuilt libraries, and sometimes we call it as your packages. So that is why if you are using your thread, remember this point again. So this thread class as well as this runnable interface, they are already there in java.lang package. So that is why in our entire this, whatever the source code you will see now, I am not going to import any package, because I am again repeating this concept is that this is the by default package. Okay, import java.lang package, even though if you are not writing, if you don't know, if you want to write, it's up to you. But if you don't want to write this thing, then our compiler will give you automatically, it will provide us this particular package, right? And this thread and runnable also comes under this our lang package. Now we want to launch a thread. We want to create our own thread. So now we want, how can we do that? So there are two ways, okay? There are two cases through which basically we can launch a thread. First is by extending your thread class. Means you have to use the concept of what? Your inheritance in your thread class. And you already know that we cannot inherit, we cannot extend interface. How, what we can do, we can implement an interface. So the second case is by implementing your runnable interface. Okay, so if you want to create your task something like related to runnable, so basically we are going to use these methods, right? So if you want to create this task, something like that. So right now, I'm not going in the depth of that thing, because after this slide, I will tell you about each and every possible solution, okay, of executing our thread. So, but the thing which you should know is that if how basically you can create a thread is basically is by creating, because we have to create, if we are basically inheriting that particular class, and how basically we can basically start a thread, we have to use this method. So using start method, okay, we are able to start our what, we are able to runnable our thread, otherwise we won't be able to run our thread. So I will give you some examples, and using these cases I'm 100% sure that you will able to understand each and everything. Now let's take this scenario. Now in this program, what we are doing, we are creating our own thread. So how we are creating our own thread? So let's take this example. So in this, so first of all, I'm just telling you the syntax, and later on, I will tell you about how to basically execute and how to perform this entire multi-threading concept. Now, so first of all, what you will do whenever the class where you want to perform this multi-threading concept, that particular class should inherit your thread class, right? And as I told you that this thread class is located where? Inside our java.lang package. Now remember this point, this is very important, is that whenever you want to perform any operation now, it is mandatory for you to override this run method. So what I mean to say is that in thread class, it is already run method, okay, public void run method. But in our thread class, this method does not contain, it doesn't contain any body. Means not body means having no implementation code. Okay, like this. So if you want to perform, if you want to achieve the functionality of multi-threading, then it is mandatory for you to override this method. Okay, it is mandatory, right? So you have to write public void run, and after that you have to perform whatever the operation you want to perform over there. Okay, so in this entire class, what we are doing, we are defining a thread, and this entire method is basically the job of a thread. What job you want, okay, what do you want to achieve from this particular main thread? So this is basically what we are going to do it whenever we are going to create a concept of our thread. So let's take a few examples, and I just want to show you some codes, and using these codes you will understand how we are going to and what output we will get. That's why I'm directly showing you this thing. Otherwise, you might have some sort of confusion. Okay. So in this program, you can see directly that I have created a class that is known as your example thread, and which is inheriting my thread class. It means I have created a thread class. You can directly say it like that. Okay. And what I have told you that it is mandatory for you if you want to perform the functionality of your run method, right? So what you have to do, you have to basically execute, you have to override this method. Remember this point, you have to override public void run method, and whatever the code you are going to write, so this is the job of your thread. Okay, this is the job of your thread. Now, in my main class, what I am doing, you already know that I am having public static void main, and inside my public static void main, what I am doing, I am creating an object of my example thread class, right? I am creating an object of my thread class. So this is what my reference variable, and this is very important. Whenever you want to initialize, okay, whenever you want to initialize that your this particular thread will execute, remember this is very important point. Okay, so you have to execute this method that is known as your start method. Now you will ask me that, sir, why are you saying that th1 dot start, but here we don't have any start method? Remember, we are using the concept of inheritance, and this start method is there inside my thread class. And if you will see the line of code, so you will find thousands of lines of code inside this for this start method. Remember, so every time we cannot write this particular method by our own. So that is why what we always do, we always directly write down th1. This is the reference variable, and you can call it as your object dot start. So using this thing, what will happen? It will automatically execute this thread as well as my this thread simultaneously. Remember this point. Simultaneously, we are able to execute our both threads. Here we are not performing sequential programming that first of all it will execute this thread, or first of all then it will execute this statement, something like that. Once we are going to execute, our JVM will execute this statement, then what will happen, I will tell you about, so that you will have a better understanding. Initially we have a single thread, okay, of our main class. Now after, once you are going to write now th1 dot start, what will happen just after this line, it will create two threads, and these two threads will execute it your what simultaneously, or we generally call it as your concurrently. Now the question that comes into your mind is, sir, then what will be the output? Okay, before telling you the output, what I am telling you is that whenever you are going to write now th1 dot start, okay, so automatically it's not like that it will execute all your methods, okay, that are there inside my this example thread class. It will only execute your public void run method. So whatever the statements that are there now inside your public void run method, which is an overridden method, right? It will execute only those methods. Remember this point. This is very important, right? Don't say keys. If I will give you some example, and if I'll ask you that how many method it will execute, don't say that if I'm going to create something like this void display. Okay, so it will not execute this statement of void display. Okay, it will execute only this your run method, okay, automatic, means after executing this particular statement. And as I told you here, then now these two threads will execute what your simultaneous. Now the question that comes into your mind is, sir, then what will be the output of this particular a program? Whether we will get example thread first, or whether we will get main thread first, or whether we will get this example thread, main thread, example thread, something like that, right? So here we cannot comment on that. Why we cannot comment on that? Because it is the role of our thread scheduler. Okay, it is the role of our thread scheduler that how it is basically executing our code. Okay, because thread scheduler will schedule which thread will execute and whatever. So there are different algorithm, right? The algorithm are like some algorithms related to first come first serve, means the thread which will come first, it will execute. Some is related to your round robin fashion, means based on the time quantum, like okay, I will give you some milliseconds, something like that. So let's check it out. So in some of them they generally use some hybrid kind of. So here you can see that we are executing example thread. Here we are executing main thread. So remember, if somebody is going to ask you, can you tell me how many number of threads are there in this entire source code? So your answer will be 2 threads. First thread is your this example thread, and second thread is our main thread. So basically you can call it as run thread, right? Now let's execute this code and see what output you will get. Now in this code, you can see here that first it is executing your main thread first, and then you are getting example thread. See, let's check the entire thing. I can zoom it here. So first you can see you are getting this main thread, and then you are getting example thread. Now let's execute this program again. Okay. So again, now here in this scenario, again we are getting first main thread, then your example thread. So whenever you keeps on basically executing this thing now, so it might be possible that sometimes you might get some different answer. So just wait. I think every time, I don't know why it is giving us the same answer when while I see. Now in this scenario, you can see here we are getting first two main thread, then we are getting example thread message. Okay, then it is executing our entire thread. So basically what I mean to say is that if somebody is going to ask you now, what is the exact output, then you can not comment on that. Okay, you can tell them the possible means what we have possible output, that either it will come first example thread or main thread, something like that. I can even show you other things. So whenever you keeps on executing now, so see, you will get different. So there is a very high probability that you are getting that particular thing. But in some of the example, like once I have executed, it might be possible that your example thread will come first. Okay, so let me execute fast so that I will get some different answer. Yeah, see here again I am getting, see, main thread, then it is executing this your example thread, right? So like this. So basically now the question that comes to your mind is, sir, what scheduling algorithm it is using? So nowadays they are using hybrid algorithm. Okay, so it depends, like we cannot comment on that. See, now you're getting different output, right? So you can get different output in some of the examples. Once you will write this code and you will find out like your example thread will come first. Okay, so there is a probability too. So right now I don't know why it's not coming, but I can tell you is that in one of my case that your example thread will come first, this particular message. Okay, so right now it's not coming. Okay, so I don't want to waste a lot of time, but what I mean to say is that by showing this example is that here we are basically first, it might be possible that it might execute this example thread first. So you cannot say that, okay, first of all, you will get this particular output only. Remember this point, okay? So in your example, in your exam, if we will give you one example, and here there are four options, and out of which your fifth option is cannot comment on that or cannot say about the output or none of the above, then always go for that particular option. Okay, like this. Now in this method, you can see directly that we are performing multi-threading. Now, what I mean to what some student will have a question is that, sir, what will happen if we are going to execute th1 dot run? Right now, whether we are performing multi-threading or not, remember, now we are not using the concept of multi-threading. Here, we are directly just calling this method, like in your current scenario, the way basically you are performing. So here we are using the concept of sequential programming, that first it will execute th1 dot run, and then it will execute your this statement, right? So this is all. See, you can see first it will execute the example thread and then you will get main thread. So every time you will execute this code, now you will get the same output. So the reason why you will get the same output, because here you are not performing multi-threading. Yes, any question?
No,
Yeah.
sir.
Yeah. So here, so remember these two terms, okay? So remember that whenever you want to initiate your multi-threading concept, whenever you want that, okay, your multiple thread should work. So always remember that you have to use this functionality of your th1 dot start. Remember this one. And if somebody is going to ask you like this output depends on what, it depends upon your scheduler, and this is your thread scheduler. Okay, it will tell, okay, which I will give the priority to which scheduler, like that. Okay, now let's take one more example
So the
and use.
scheduler
Yes.
works randomly, means there is no fixed thing about which will be run first and which will run afterwards.
Yeah, no. There will be no fixed thing. Okay. Otherwise, what we have to do now, we have to see the in-depth means the algorithm. Okay, how there. So it depends upon different compiler to compiler, or it depends upon different machine to machine. How basically our thread is executing. See, because the way basically our thread is executing now, not only on the basis of our line of code, but on the basis of resources also. So there are various factors. Got it? Like your processors, your memory, your variables. So it is taking care a lot of things. So that is why we cannot comment on that. So you can say that, yeah, somehow randomly, but it's not like that. It will give you some different output. It will give you either this thing or this message. Okay. The message will see, yeah, but the order, you can say that you cannot comment on order. But yeah, if we will give you some example or some statement that, okay, the scheduler which we are using over there is first come first serve. Okay, while we cannot give you for this thing, but this thing you will learn in your operating system. Okay, first come first serve means the schedule, the process, the thread which will come first, we are going to process first. So in that scenario, it will always execute example thread first. But for our Java language, you cannot comment on it. So if you are interested, you can, that is a very good thing. What you can do, just try to figure it out. How basically our scheduler is basically working. Okay. It's not that much complex, but if you are interested, then you can basically find it out. So there are various factors like your resources and all something like that. So I don't want to discuss about that thing because otherwise our entire lecture will get means its length gets increased. Like that. Okay. So basically you got your answer. Okay.
Yes, sir. Yes, sir.
Okay, yeah. So you can say, yeah, it's kind of a random. Now, second thing is basically related to your method overriding. Okay, so method overloading, sorry. So here you can see if somebody is going to ask you, can we perform method overloading here? So yes, you can perform method overloading on your run method. Okay, so for method overloading, in case of run method, it is possible. So if you are going to execute this code, so you will get the output again. See here what output for this for this basically. Let's check. See here you are getting, see, first parent method. So the code is same. First parent method, then you are getting child, then you are getting parent method. Let's check it out again. So every time, see, you are getting different output, right? Like this. So you can find. So based on the resource utilization, what they have done, This is the entire operation of our thread scheduler. So I'm going to cover this thing too. Now let's take one more example, and in this example what we have is basically we have created a class, and in that class we don't have any run method. Remember, here we don't have any run method. Now if I'm going to ask you why I'm going in the depth so that you will have a better clarity, if I'm going to ask you like if I'm going to execute this code, what output I will get, then don't say, sir, we will get a compile time error. Why? Because don't say like that, because what I have told you is that in our thread class we already have this method that is known as your public void run method. But remember that in our thread class, that particular method contains no body. Means it is not an abstract method, but still that method does not contain any implementation body. So if I'm going to execute this code, so you can see here that I am getting a blank screen. See, I have executed this thread. Okay, so both these threads are executing. So we don't have anything to display. So that is why we are not getting anything. So don't say that we will get an error over there. Now let's take one more example. And in this example, make it, yeah. So in this example, what we have a start method. See, now what we have done here, we have overridden start method. So what I have told you, this thread class contains start method as well as run method. And in most of the scenarios, whatever the thread operation we want to perform now, we always put it inside our run method. Now what we want to override this method. So now we have performed this overridden. We have overridden this method. So if somebody is going to ask you, can we perform method overriding? So remember, yes, we can perform method overriding because this method is public void start. So yes, we can override this method. There is nothing related to private and something like that. So yes, we can override this method. Now the question that comes into your mind is, sir, are we performing multi-threading over there? Are we using the concept of multi-threading now if I'm going to call th1.start? No. Remember, here we are not performing the concept of your multi-threading. Now the question that comes into your mind is, sir, why we are not performing? See, for this start method now, in thread class, you will find that they have written thousands of lines of code, right? And here we are just displaying this method. So if I'm going to call this method now, so it will directly call this particular method. So it's kind of a sequential programming. So here, if I'm going to execute this code, so you will see directly that it will not execute our run method, right? So let's execute this code. So once I will execute this code, see output, what output I'm getting, thread and parent thread. So this is what thread and this is my parent thread. But I am not getting child thread. While in our earlier case, if I am going to remove this thing, so now if I am going to execute my code now, so now you will see that I am getting, see what I am getting? I am getting parent thread as well as child thread because our start method will basically execute our run method. So I am basically giving you the possible combinations. What are the possible combinations that are there? Okay, so now here in every scenario it is executing first. Okay? So still we cannot comment on that if still, so there might be some cases, okay, where your child thread will execute first, like that. Okay, I don't know why. It might be possible we have very less number of statements, that's why it is executing our parent thread first. Okay, like that. Okay, so till now we have understood though that thing is that please don't override your what we call it as your start method, because if you are going to override this method, you are not able to perform the concept of multi-threading. Now let's take one more example, and in this example what we want to call our parent class thread. So can we call our parent class thread? So yes, we can call. So you already know about this keyword. That keyword is your super keyword. So see how we are basically using the functionality of these keywords. Now you already have an idea about entire things. So now you are also feeling comfortable, right? So now you will tell me directly that yes, sir, it is possible. It is possible because using super keyword, we can directly call our immediate parent method, this particular method. So once we are going to call now, again, now we are able to perform multi-threading, right? So now if we are going to execute this code, see, we will get three statements: thread, parent thread, and your child thread. See what we are getting: thread, parent thread, as well as child thread. Even though we are not calling, you can see directly here, we are not calling our run method, but because of this method, because in this method the functionality which they have added is that you can perform multi-threading, means parallelly you can execute your program, and whatever the statement that are there inside your run method, you are able to execute those methods. So let's check it out. So if you are going to execute this code, so again, I think because we are having some less number of statements, so that is why we are getting the same output, but still we cannot comment on that. Okay, so don't say that okay, for less number of statement we will get the same output. No, it depends upon machine to machine, and there are many things. Okay, so for that we have to check out the functionality of our schedule. So here we are getting, I think, the same output, but once I have checked now, I got like this output: parent thread first, then child thread after, like that. So you will find that this thing. Okay, now, so like this, and one more thing. Okay, so this is all about what? So what I have told you is that entire thing about whenever we are having this main class, and after main class, whenever we are having this thread T1, T2, suppose T1, T2 thread. So which thread will gets executed first? So suppose you have a uniprocessor. Okay, so a processor can execute only one process at a time. Either it will execute this process or this process, right? So what it will do, it will process this process at a time, and somehow if it is performing some other operation during that duration, what it will do, it will execute our T2 thread. So right now, actually, we are not basically, we are just going through the basic examples of thread. Right now, we are not basically going for the main utilities. Okay. So otherwise, you will say that here, sir, what is the advantage of multi-threading? For this scenario, you might say that, okay, the advantage is not that much supreme for our present example. But whenever I'm going to tell you about the exact examples, okay, where we required multi-threading, then you will find out, okay, we can perform multiple tasks, we can perform multiple task at us with a very minimum number of time, like that. Okay, so it is a part of our JVM. As I told you, it is responsible to schedule thread if multiple threads are waiting to get a chance of execution, in which order threads are executed is done by the thread scheduler. Okay, so I've already told you about the functionality of our thread scheduler. So thread scheduler will tell us about the order of execution. Okay, so just I'm going to end this session by just going through these two statements. We can expect exact algorithm. See, we can expect exact algorithm followed by your thread scheduler. It is varied from JVM to JVM. So see, it is varied from JVM to JVM. Hence, we cannot expect the execution order and exact order. Hence, whenever there is no guarantee of your exact output, we can provide all possible outputs, right? Like this. So all these things we have learned so far is related to threads. Now we will somehow increase our difficulty in next lecture. So in today's lecture, we have discussed about what do you mean by multi-threading, how to create threads, and what are the possible combinations. Okay. So in our next lecture, we are going to discuss about the life cycle, and then there is a other way also. Okay. So there are two ways now. So I have just discussed about the first way, and the second way is related to your interface. How can we create a thread? Okay, and which one is better, we are going to discuss about in our next lecture. Yes, is there anyone